Good evening, dear students. Let's start our class now. Today we are going to, continue our discussion on ellipse as we, discussed in our previous couple of classes. So we will start today from, equation of normal to the ellipse, and after that we will proceed with the other, topics. For example, after that we will go to the chord joining 2 points of the ellipse, pair of tangents from an external point, chord of contact, and finally chord of contact in terms of middle point. So dear students, so first we will start with the equation of an normal of an ellipse. Okay, normal of ellipse, that is the point of discussion. Now dear students, before I proceed further, could you someone please confirm that you are able to hear my voice very clearly and able to view the screen properly, dear students?
Yes.
Okay, great. Thanks for the confirmation. Yeah, I just take this formality to make sure that everyone is able to hear my voice and very clearly and able to view the screen very properly. So as you know, we have discussed in this coordinate geometry discussion series what is normal. Okay, for any curve, if I take, for example, in fact, we can take the curve as as ellipse here, and if I what is meant by a normal to an normal of ellipse. Suppose let's consider this is an ellipse, and in that ellipse we take an arbitrary point. Suppose this is the point we take, and this is an arbitrary point, suppose P. Now, dear students, in this point P, we can draw a tangent. Okay, so how the tangent will looks like? So if I draw the tangent in the green color straight line, so this is a equation. This is a tangent. In our previous session, we discussed about what is equation of tangent to an ellipse. Now today, what we are going to discuss, we are going to discuss the normal to an ellipse. And before going to discuss on that equation of normal to an ellipse, just let's understand quickly what is meant by a normal. Normal is nothing but a straight line which is perpendicular to the tangent at the point where the point under consideration of that ellipse. That means what? If I draw the normal to that ellipse, so the normal will, if I draw the normal in the blue color, so normal will be a straight line something like this. And dear students, that normal and tangent, they actually intersected at the point on the ellipse, and the angle between them is 90 degrees. That we are all aware of. Okay. Now, our purpose of discussion now is that to find the equation of the normal, that is the equation of the blue line. And here it is, dear students, is that if we take the equation of that ellipse as x square by a square plus y square by b square equal to 1, then we get the equation of the in normal at an arbitrary point x1 comma y1 as x minus x1 by x1 by a square is equal to y minus y1 by y1 by b square. If the point is an arbitrary point with coordinate x1 comma y1. Now, if the point P is a parametric point, that means if you recall, dear students, in the previous session we discussed about the coordinate of a point in parametric form to an ellipse. If someone wants to go through it, you can go through my previous lecture, which is available both in the online platform at KonarClasses.com as well as it is available in YouTube. So that arbitrary point having coordinate a cos theta comma b sin theta, and the equation of that normal to the ellipse at that parametric point theta, because theta is the parameter, is ax sec theta minus by cosec theta is equal to a square minus b square. So dear students, so these are the two equations of two forms of equation of an ellipse, normal to an ellipse, when the point is an point x1 comma y1, which we commonly know as a point in a Cartesian coordinate system, and the next one is that parametric point. So this is all about normal of an ellipse. Now, dear students, what I'm going to discuss now is that chord joining 2 points on the ellipse. That means what? So let us consider an ellipse and let us consider the 2 points on that ellipse, something like this. So let me bring the diagram first, dear students. So if you see, dear students, chord joining 2 points on the ellipse. So here are the 2 points, alpha and beta. These are the parametric points, by the way. P alpha, P in bracket alpha, that means what? That is a point P on the ellipse, x square by a square plus y square by b square equal to 1, having coordinate a cos alpha, comma, b sin alpha. Similarly, the point Q having, mm, having a parametric point beta, so its coordinate is a cos beta, comma, b sin beta. Then what we are going to find? We are going to find the equation of that line segment PQ. Okay, that where the P and Q are the 2 points on that ellipse. So how we are going to find it out, dear students? So there is a formula for that, and you need to remember this formula, and you need to apply this formula. Not only remembering, you need to apply as and when required while solving the problems. Okay, so here I'm writing, dear students. So that I'm bringing it from that online material, that of our study material. The equation of the chord joining the end points P having coordinate, as you see, a cos alpha, comma, p sin alpha, and Q having coordinate a cos beta, comma, b sin beta, of the chord of the ellipse x square by a square plus y square by b square equal to 1 is x by a into cos of alpha plus beta by 2 plus y by b into sine of alpha plus beta by 2 is equal to cos of alpha minus beta by 2. And dear students, it is important that you remember this thing. You can derive also, but finally after derivation you need to remember it so that you can apply this formula whenever relevant problem comes. Okay, dear students, so this is all about the chord joining 2 points on the ellipse. Our next point of discussion, dear students, is the pair of tangents from an external point. Let us understand what is meant by the pair of tangents from an external points. We have we earlier we had discussed the similar thing for the other conic sections, and here we are going to discuss on ellipse. So for example, so let us understand this particular statement, that is a pair of tangents from an external point. So let me first draw let me first draw one ellipse. So dear students, so let us consider this is an ellipse. Okay, and in that ellipse, okay, so let us consider a point here, a point, external point. You see the word external is there. So let us consider a point P, and we can consider that coordinate of that point PB x1, comma, y1. Now if you start drawing the tangent from that point P x1, comma, y1 to that ellipse, then you can draw 2 tangents, right? So let me draw those 2 tangents in green, in blue color, suppose. So one tangent will be something like this, correct, dear students? And the other tangent should be something like this. Now, dear students, if you recall, so let me draw it very clearly. Now, dear students, if you recall, this is these 2 blue lines, these are the pair of tangents from that external points x1, y1. Now, these two lines together represents a pair of lines, and we are going to find the equation of that pair of lines. How? That I'm going to show you in another few seconds. So what are the two points we are aware of? One is that equation of that ellipse. That is a standard equation, dear students. That is x square by a square plus y square by b square equal to 1. And a fixed point which is external to the ellipse. And a fixed point which is external to the ellipse. And that coordinate of that point is x1, y1. Now, dear students, from that external point, that x1, y1, as we draw two tangents, as you see it in the blue color, what is the joint equation of those two tangents? That is represented by this equation, dear students, is that s1 equal to t square. This is a symbolic way of remembering this a pair of tangents, where s is the expression x by a square plus y, x square by a square plus y square by b square minus 1. And what is s1? S1 is nothing but the same expression s, but you just replace x by x1 and y by y1. And the tangent t is that x1 by a square plus y1 by b square minus 1. Dear students, here we should not get confused with the tangent t. If you look into this particular equation, that is x1 by a square plus y1 by b square minus 1 equal to 0, as if that the point x1, y1 is on the ellipse, and this is the equation of the tangent. But here the situation is completely different, because the point x1, y1 is not at all on that ellipse. It is outside the ellipse. Then you may ask, sir, then why, sir, you wrote t square? It is just written so that you can easily remember. Correct. Otherwise, if I do not use this particular way of remembering that s1 equal to t square, then what you need to do? You need to do, I need to tell like this thing: the equation of the pair of tangents drawn from an external point P with coordinate x1, y1 to the ellipse x square by a square plus y square by b square equal to 1 is x square by a square plus y square by b square minus 1 into x1 square by a square plus y1 square by b square minus 1 is equal to x1 by a square plus y1 by b square minus 1 complete whole square. That will be a little difficult to memorize, but the point is that if you remember s1 equal to t square, it is easily you can remember. And in fact, this kind of formulas also we have used for the other conics as well. Now, what is s? S is nothing but the expression corresponding to the equation of the ellipse. What is the equation of the ellipse? I want to spend some time here, dear students. So if you see, the equation of the ellipse is, x square by a square plus y square by b square equal to 1. That is the equation of the ellipse. Now, what is the corresponding expression? The corresponding expression is that, this is the equation, but the corresponding expression is become x square by a square plus y square by b square minus 1. That is the corresponding expression. Okay, and that expression we symbolize as s. Then what is s1? S1 is nothing but replace x by x1 and y by y1, you will get another expression s1. And then what is t? T is nothing but, as I said few minutes back, as if it is the equation of the tangent to the ellipse x square by a square plus y square by b square equal to 1 at the point x1, y1. So just to memorize that, we are remembering that, okay, we are recalling that as if x1, y1 is on the ellipse, but actually it is not, as I said. I think I said a couple of times, so you understood why it is so. Just to remember, I wrote like this, and you should also remember in the same pattern that s1 equal to t square. So that is about the pair of tangents, from an external point. Now, dear students, the next point what I am going to discuss is the chord of contact. Okay. So what is chord of contact? Let me first explain you the chord of contact, and then we will discuss that in what context it is coming as long as the ellipse is concerned. Okay. So the chord of contact is something like this, dear students, is that, let us first, let us first consider the ellipse. Let's get a visual representation of the ellipse. So if we get a visual representation of the ellipse, so it will be something like this, correct, dear students? And from an external point, suppose this is ellipse, and we get an external point P. Okay, dear students, and we know the coordinate of the point, and that coordinate of the point is, suppose, x1 comma y1. Now, dear students, from that external point P, we having coordinates x1 comma y1, we are able to draw two tangents. Let me draw these two tangents in the blue color. So this is one tangent, and this is another tangent. And let's assume these two tangents, touches the ellipse at two particular points. One is the point A, and the other is the point B. Now, dear students, we can join these 2 points A, B, and we will get a chord of that ellipse, correct or not? So if I draw the chord in the green color, so it will be something like this, correct, not, dear students? So what you see, dear students, in the green color, that is a chord. So we have two things, in our hand. First one is that coordinate of the point, external point, that is x1 comma y1. And so let me write it down, dear students. So what we have is, the point, that external point. First we have that external point, and that external point is P, having coordinates x1 comma y1, and that ellipse. And what is the equation of the ellipse, dear students? It is x square by a square plus y square by b square is equal to 1. Now, as we see that the two tangents as we draw, and it touches the ellipse at the two distinct points A and B. Now, the straight line AB is called the chord of contact. And dear students, what will be its equation? Its equation is t equal to 0. In the similar manner, just I said few minutes back, the way you need to remember t, the equation of the tangent to the ellipse, x square by a square plus y square by b square equal to 1 at the point x1 comma y1. So dear students, so symbolically we remember this thing, but like the previous case, here also the point x1 comma y1 is not on that ellipse, so that there is no question of having an equation of a tangent. It is just a symbolic representation to remember it. Okay, so what is the equation of that chord of contact? It is t equal to 0, where t is nothing but the value of the expression x1 by a square plus y1 by b square minus 1. And if you recall, x1 by a square plus y1 by b square minus 1 equal to 0 is the equation of the tangent to the ellipse x square by a square plus y square by b square equal to 1 at the point x1 comma y1, which is on the ellipse. Then we can say this is t equal to 0, that expression equal to 0 is the equation of the tangent. But here is the case is completely different, dear students. Here the point here the point P is external to the ellipse. We have drawn two tangents, as you see in front of you. It's in the blue colors. Now those two tangents actually touches the ellipse at two distinct points A and B. Now we took these 2 points A and B and joined that line, which is green color, as you see, that is AB. That is known as the chord of contact. and its equation is nothing but t equal to 0 as a symbolic representation, or other way we can say that its equation is x(x1) by a square plus y(y1) by b square minus 1 equal to 0. Correct, dear students? Sorry, extremely sorry. Now, the next point, that is the last point as long as the theory is concerned. It is the equation of the chord of contact in terms of the middle point. So let me first explain you this, particular, significance of this statement by means of an, visual representation, and then we are going to find the corresponding equation of the chord of contact in terms of a middle point. Now, dear students, let me first have the ellipse. So let us consider this is the ellipse, okay, and that ellipse is having a chord, okay, and let me draw the chord in suppose in green color. So this is a chord, okay, dear students. So this chord, as you see, is in the green color, and dear students, we do not know what is the equation of this chord. That means it is a straight line, the green color, it is a straight line, but we do not know. We only know it is a chord. Okay, but one point we are aware of, that chord, intersected the, the ellipse at 2 points A and B. Suppose, let me write it down, the red color. So this is the point A, and this is the point B. Dear students, what do you know? We know what is the coordinate of the midpoint of the line segment AB. Okay, and that we are aware of. And let's consider this point is the point P. And what is the coordinate of the point P, dear students? So let's assume the coordinate of the point P is actually, okay, let's not consider it is a P. P is something different. So P, generally we consider it is a point, external to the ellipse. So let's take this is the coordinate of the point B, suppose C. And what is that? Its coordinate is x1, y1. So we have two information in our hand, dear students. The first one is that equation of the ellipse, obviously. So what we have? We have that equation of the ellipse, and that is a standard equation, as you know. It is x square by a square plus y square by b square is equal to 1. Let me write properly, b square equal to 1. And we know the coordinate of the point C, which is the midpoint of the chord. Okay, so midpoint of the line segment AB, midpoint of the line segment AB, and that is nothing but C, and having coordinates x1, y1. So with these two information, we are going to find what is the equation of the chord of contact, or in other way, we are going to find the equation of the green straight line. So how we are going to find it? I'm going to show it to you, dear students, the relevant, portion by taking it from our study material. And here it is. So dear students, so here it is. Let the pair of tangents drawn from an external point P to the ellipse x square by a square plus y square by b square equal to 1 touches the ellipse at two distinct points, say A and B. And we know the coordinates of the middle point of AB, which is x1, y1, and we represented this by point C. Now, the straight line AB is called the chord of contact, and its equation is given as t equal to s1, where t is the value of the expression x1 by a square plus y1 by b square minus 1, and s1 is the value of the expression x1 square by a square plus y1 square by b square minus 1. And the equation of the chord of contact in terms of the middle point is something like this. Dear students, with this, I would like to conclude that as long as the theory of the ellipse is concerned. If you have any question to me, please do let me know. Okay, if you do not have any question, perfectly fine.